In the previous video, we saw that we are able to solve trinomials by completion of square. Now we're going to learn something called a quadratic formula. The method we just learned, the completion of square, is all nice and good. It would be better to have a formula that works for all cases. Here we derive the quadratic formula using the completion of square. So this is the goal. We're given a general quadratic, ax squared plus bx plus c equals 0, where a, b, c are real numbers, constants, not variables. Now find what is x. Now the answer is going to be in terms of a, b, and c because these a, b, and c may vary. So here's the work. First of all, just as in the last example in the previous video, we divide everything by a in order to get rid of this coefficient. Now this, to complete the square, we need to add and subtract b over 2a, which gives me x plus b over 2a squared, and I have this plus minus term, and I eventually end up with this quadratic formula. Now it will be nice for you to try this on your own, or try to derive this, and then you can check your calculations with the notes here. Once you've done that, you can also do a concept check of trying to find a formula for x squared plus bx plus c, and then you can verify by plugging a equals 1 into this solution. Okay, example, I worked out the first one so that this was for prior to watching the video. I'll work out the remaining examples. Okay, here a is 1, b is negative 1, c is negative 1. So x is negative b plus minus b squared, that is 1, minus 4, 1, negative 1 over 2 times 1. That's 1 plus minus root 5 over 2. Now this is the same number that you've seen before in exam 1 and also in the previous homework or the previous worksheet. Here, before you apply the quadratic formula, you move everything to one side and it's equal to 0. A is 2, b is negative 4, c is negative 1. So x is negative 4 plus minus negative 4 squared is 16. 4 times 2 times negative 1 divided by 2 times 2. That becomes 4 plus minus 16 plus 8 over 4, which is 4 plus minus root 24 over 4. Now this is perfectly fine, but since we've learned how to work with radicals, you can simplify this further as 2 root 6 over 4, which becomes 2 plus minus root 6 over 2. So this is the simplest form. And now here again, first step would be to make everything equal to 0. And then you apply the quadratic formula for a equals 3, b equals 4, and c equals 2. That gives you x is negative 4 plus minus 16, that's 4 squared, minus 4 times 3 times 2 over 2 times 3. That's negative 4 plus minus 16 minus 24. So we're going to have a negative number in the square root here. Well, that's fine because we know how to work with negative square roots now. That's plus minus I root 8 over 6. Now again, root 8 can be written as 2 square root of 2. So this is I 2 square root 2 over 6. And I can simplify this a little further by cancelling out the factor 2, and this is the simplest form of the solution. One last example, 3x squared plus 6x plus 5 equals 0, negative 6 plus minus 36 minus 4 times 3 times 5 is 60 divided by 2 times 3 is 6. That's negative 6 plus minus root 24, negative root 24 over 6. That's negative 6 plus minus 2 root 6i over 6. Again, a factor of 2 can be cancelled out to give negative 3 plus minus root 6i over 3. So those are just examples of quadratic formula. Now in this previous example, sometimes the solution is real, sometimes the solutions are complex numbers. Another observation is either both the solutions are real or both of them are complex. It's never a mix. The complex numbers are conjugates of each other. Recall conjugates, we defined that when we learned complex numbers. Let me go back here. The two solutions that we found here, see these are plus and minus, plus and minus. So they are conjugates of each other. So one question to ask here is what determines the nature of the solution? And by nature, we mean real or complex. In general, this is what x equals. The only place where a complex number can arise is when you have a negative inside the square root. So whether the answers are real or complex depends on the sign of b squared over b squared minus 4ac. We'll give a special name to this expression. We call it the discriminant, denoted by d or a triangle, which is a Greek for delta. If this d is more than 0, the solutions are real and distinct, meaning there are two solutions. If d is 0, we have one solution equals negative b over 2a. You can verify here. If this part is 0, you're just left with negative b over 2a. If d is negative, then you have two complex solutions and they are conjugates of each other. So this means if I have to find the nature of solution, I don't have to really find the solution. I can just find the discriminant, which is negative 6 squared minus 4 times 9 times 1, which is 36 minus 36, which is 0. So these are real, but there is only one solution. The last topic here is creating quadratic equations. Now recall, when we factored x minus 3 and x plus 4 equals 0 means x equals 3 and x equals negative 4. Now in reverse, if we know that x can be 2 root 3 and x can be negative 2 root 3, what is the quadratic equation? So it must be x minus 2 root 3 times x plus 2 root 3, which you can then FOIL x squared negative 2 root 3x positive 2 root 3x and 2 times 2, which is 4, and root 3 times root 3, which is 3. So you end up with x squared minus 12. In the next video, we're going to look at graphs of quadratic equations.